Hi, welcome back. In the previous video I had asked you a question. The question was, if the mass of an object is 0.1 kg, what would be the weight on moon, right? We discussed the weight of the object on earth would be formula. What's the formula? M into G, so mass multiplied by gravity on earth. So mass, I gave it to you as 0.1 kg, so 0.1 multiplied by 10, you will get 1 Newton. So this is the weight of the object on earth. Now the same if you take it on moon, and if you measure its weight, then mass multiplied by gravity. Now how is the relation of gravity of earth and moon? Earth, the gravity on moon is actually 1/6 of the gravity on earth. Okay, so mass actually there is a value like but here I would substitute it as, so 0.1 multiplied by gravity on earth is 10, so it is upon 6. 1/6 of 10 is the gravity on moon. So this answer will lead to 0.1666, it goes on, so 0.167 Newton. Okay, so this is the weight of the object on moon, and this is the weight of the object on earth. So you can see the difference, it's 1 Newton, and here it's only 0.167 Newton. All right, that was the answer to the previous question. All right, today's class, what are we going to see about? As I have written here, we'll see how to interpret motion graphs. When I say motion graphs in IGCSE, mainly you need to know about distance time graph and velocity time graph. Now the technique that I tell my students to remember or to interpret this easily would be always compare and learn. So while you're analyzing graphs, or you're just learning about very basic shapes of the graphs that are drawn, I would advise you always have a comparison of dt and vt. If possible, take a screenshot after, in between when I finish drawing all those shapes. That will kind of help you. Now why I have drawn it side by side, or why I insist on learning it by comparing, is you will have similar shapes on both these graphs. Okay, you may have a horizontal line, you will have inclined line, curves, curving upwards or curving downwards, etc. So if you have a comparison, then it will be easy for you will not get confused. Okay, so that's the reason I tell you, while learning itself, have a comparison. Now before going to the motion graphs, now the 4 different states of an object, keep that in mind, so that you will use the correct terminology while you're interpreting graphs as well. What are the 4 main states of an object? Would be, an object can be at rest, or it could be moving at uniform speed, or it could be accelerating, or it could be decelerating. Correct? So it could be, one would be at rest, second would be uniform speed, third would be accelerating, fourth would be decelerating. Okay, so have this in mind while you're analyzing graphs. Okay, now I come to accelerating and decelerating. There also you have uniform and non-uniform. We'll come to that in a bit. Now coming to the shapes of the graphs. Okay, the main shapes that you will be expected to analyze would be a horizontal line. Okay, a horizontal line, it could be in a VT graph, velocity time graph, or in a distance time graph. Correct? Now the best way to first analyze, to practice, is look at the quantities on both the axes. From the quantity you try to start thinking. Okay, now what does this flat line represent? Now as time increases for this interval of time, okay, say if you take it as, say this was from 1 second to 2 seconds, so from 1 to 2 seconds, if you notice, there is no increase or decrease in the quantity on the y-axis. That right? I repeat, for this interval of time period, there is no change in the quantity on the y-axis. If you come to this, here also the same explanation. For this particular interval, this quantity on the y-axis doesn't change. All right. Now, when I say that quantity, what is the quantity here? The velocity does not change for this period of time. The velocity does not change, which means the velocity is constant. Correct? But how about in this case? This is where students can tend to get confused. Here also, they tend to say the object here is at rest or there at rest. I do not know, etc., etc. But then, as I said, here first thing is your quantity on the y-axis does not change. So start the sentence from there. The distance or displacement that is plotted on the y-axis does not change. Here velocity does not change. Got it? Now, in real life, what do you mean by if the distance does not change for an object? The distance traveled by the object is the same for this period of time, meaning it is at rest. So this could be part of a journey. Say for example, the car starts from 0 seconds and travels a distance, and probably it has stopped here at a signal. Okay, so this is a portion of a graph where the object is not covering any distance, which means the object is at rest. Right? But how about here? It is traveling at uniform speed. It is not at rest. It is traveling but maintaining the same speed throughout. So how do I represent the object being rest on a velocity time graph? What would the velocity of an object be if the object is at rest? I repeat, what would the speed of an object be if it is at rest, if it is not moving? 0, correct? It is not having any speed at all, so it will be 0. So for, say for example, for the first second, the speed of the object is 0 or the object is at rest. That means you will have no increase in speed at all. So this is where you have the object being at rest on a velocity time graph. Clear? So we have seen now 3 different flat lines. Now one is here in distance time, here it is uniform speed, here is at rest. Now if you have it here, say initially if the object was at rest, it could also be here as well. On the x-axis also you can have, but this part is like it has traveled a particular distance, then it is at rest. So I'll give you an example. From home, like for 2 seconds you are at rest, then you are traveling for 3 seconds, then you are reaching the signal, at the signal you are at rest. Getting it? But here, if you have a flat line in a velocity time graph, that does not mean the object is at rest, it's traveling at uniform speed. Got it? Now, if I have, say here, from this part, if I have an angled line, okay, or an inclined line, say here also I have an inclined line, so just take a bit. Okay. What does this inclined line in these 2 graphs represent? Now, flat line we have discussed. So when you have an inclined line, first you have to think about is the gradient of the line. I repeat, the gradient of the line. What is the gradient of the line equal to? Gradient means the quantity on the y-axis upon the quantity on the x-axis, right? So here gradient will be equal to distance upon time, which is equal to velocity. Correct? The gradient is represented by the velocity. How about here? Gradient will be change in velocity upon time taken. So that will be equal to acceleration. So the gradient from a distance time graph is represented, as velocity. The gradient on a velocity time graph is represented as acceleration. Keep that in mind and then approach what is happening to the gradient. Now here, is there any change in the gradient? Is there any change in the slope of the line? No, it's just a steady rise, right? So the slope is constant, meaning the velocity is constant here. So this portion, velocity is constant because the gradient is constant. Got it? How about here? Here also the slope is constant, but what is that slope equal to? Equal to acceleration. Okay, hence here acceleration is constant. Got it? So remember these points. Second point, what did I tell you? If you see an inclined line, first think about what is that inclined line's slope equal to. Slope, how do you find? Or gradient or slope, how do you find? The quantity on the y-axis upon the quantity on the x-axis. So distance over time will give you velocity. Velocity over time will give you acceleration. So if the slope is constant, that means the acceleration there is constant, velocity here is constant. Got it? Now we are only seeing the basic structures, little complicated ones we'll see it in a later video. Now if you have another slope here, this part, what would you say here? Here also gradient is constant, right? Gradient is constant, but what is happening to the distance? The distance is decreasing, right? So that means it is coming back to the starting point. If it was a displacement time graph, from a starting point it has traveled a particular distance, then it was at rest for few seconds over a period of time, and then it is coming back to the starting point. This is not decelerating. Here the gradient is constant, means velocity is constant. At a constant velocity it is coming back to the starting point. Clear? Here we have a line here. What is happening to the velocity? The velocity from a positive value is coming back to 0, meaning it is slowing down at a constant rate because slope is constant. It is coming back to rest. It is decelerating uniformly and it is coming back to rest. So we'll compare. See, here we have almost similar shapes in both distance time and velocity time. Now if you have a flat line here or here, it represents the object being at rest. Now if you have a line, inclined line climbing up, then you have the velocity to be constant because the gradient is constant. If the inclined line is coming down, gradient is constant, but it is traveling in the opposite direction. It's coming back to the starting point. Now here it is accelerating at a constant rate, maintaining constant speed, and decelerating at a constant rate and coming to a stop. I hope it's somewhat clear. Now we'll see about curved graphs in a bit. Now I've drawn two curves here. Let's see how to interpret curves in these graphs or any graph for that matter. Again, keep that point in mind. Gradient equal to the quantity, that is velocity here. Velocity will be equal to the gradient. Here acceleration is equal to gradient. Now how does the gradient change here? If you look at it, the gradient is not constant, but instead it is getting steeper, right? If you look at the gradient of the graph, it is getting steeper as the time increases, right? Here also it's the same, it gets steeper as time increases. So how do you put it in words? How do you interpret the graph? Gradient is equal to velocity. So the velocity is increasing here as time increases. So V is increasing. In other words, the object is accelerating. Correct? Velocity is increasing because the gradient is increasing, hence the object is accelerating. How about here? Similar explanation, but in this case, instead of velocity, you will write acceleration. Now the acceleration is increasing here. Acceleration is not constant, acceleration is increasing. As time increases, the rate of acceleration is increasing. Now if the curve was in the opposite direction, what would you say about the gradient? The gradient is decreasing. The gradient is decreasing. You can see here it is steeper. As time increases, it's becoming more and more inclined. So from steep to gentle it is becoming, that means the velocity is decreasing. Similarly, if you have a curve here, the acceleration will be decreasing. So both here the accelerations are not constant, they are non-uniform acceleration. Here we have this part is accelerating, this part is decelerating. So compare these two and study. I hope you would have understood at least a few points, and you'll be careful enough to avoid mistakes. And I'll give you a couple of questions to solve, and the answers I'll give you in the following video. Bye. See you later. The questions are: Part A, mark a point labeled A where the car is moving at constant speed. Then B, where it is decelerating at uniform rate. Then C, the section where it is decelerating at non-uniform rate. Try to identify the three sections. I'll give you the answers in the second video.